In this video, we're going to discuss the behavior of the harmonic series 1 over k as k goes from 1 to infinity by comparing it to an integral. So let's talk about what integral we can compare it to. So right here, we're going to look from 1 to 10 for the function of 1 over x. And there's a particular reason we're going to do that, because it makes for a nice comparison to this harmonic series. But let's talk about what this Riemann sum is. So we can see it's a left-hand sum. So if we were to write up the sum for this, the Riemann sum would be from 1, let's use I equals 1, and it's a left-hand sum, so it's ending at 9, not 10, because the left hand is going across of 1 over I times our delta x, but our delta x in each case is 1. So times 1. And so what we get is actually basically just the first 9 terms of our harmonic series. So this is our Riemann sum, but it also turns out it's actually the first 9 terms of our harmonic series. Now the definite integral that we're looking at is the integral from 1 to 9 of 1 over x dx. That would give us the area under this red curve. Now if we wanted to see which is larger, notice the area under the curve is less than our Riemann sum. We could also say we have a decreasing function, so our Riemann sum is going to give us an overestimate. So we know that the integral from 1 to 9 of 1 over x dx is definitely going to be less than our summation from, we can use I or k. I'm going to go ahead and use k to match it up with our harmonic series there. Now, this is going to be true because we got a decreasing function the whole time as n goes to infinity. So taking the next step, we're going to generalize and say that the integral from 1 to infinity of 1 over x dx is going to be less than our summation from 1 to infinity of 1 over k. Now, this is an important fact because think about what we know about this improper integral. And we can recalculate it if we want to. Let's go ahead and do that for practice. The limit as b goes to infinity of 1 to b of 1 over x dx, that's going to be limit as b goes to infinity of ln absolute value of x from 1 to b. So we have the limit as b goes to infinity of ln of b minus ln of 1, which is 0. As b goes to infinity, ln of b goes to infinity, so this limit does not exist. This improper integral diverges. Well, if our improper integral diverges, and this is greater than something that diverges, then we have to conclude that this series, our harmonic series, diverges. And what we're going to see is that we're going to be able to call this the integral test in using improper integrals to determine whether or not a series converges or diverges.